Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the June 2024 International A-Level Edexcel Pure Mathematics P3 paper. And this is the final question on this particular paper. And we have been given this curve, which is defined as x equals 4 sine squared y minus 1. And they've defined it with a range from 0 to pi over 2. So on the y, see, this is like pi over 2 from 0. So this is like an inverse function, inverse trig function. If you rearrange it for y, you'd have arc sine or inverse sine y there somewhere. Anyway, so this is the function given and the range that we're supposed to consider. It says a point P, K, pi over 3 lies on the curve. Verify that K equals 2. Now, important for us to remember here the limits are given in terms of pi. Okay, and also the coordinate here is given, as an angle in terms of pi. So we have to make sure that, we're dealing with radian mode in our calculator. So that's the first thing we should always, what I would start with here is to put it in radian mode. And one of the things about this type of question where they say verify that K equals 2, is that if you forgot to put it in radian mode, you will find that your K is not equal to 2 and you'll start beginning to ask yourself, why am I getting the answer wrong? Then hopefully you realize, I forgot to put it in radian mode. So that's one of the reasons why I think they start off with this, where they tell you what the value of K is. So in this particular case here now, we want to basically use this equation. The P, let me just get the pen back. The coordinates of P are K and pi over 3. So that means when x equals K, y equals pi over 3. Okay, that pair of values. Well then, if we put it in here, we'll find what K is. So x is K, so K equals 4 times sine squared of pi over 3 minus 1. Now remember, what this actually means is 4 times sine of pi over 3 squared minus 1. And we know that pi over 3 is 60 degrees. And the sine of 60 degrees, so the sine of pi over 3 is going to be root 3 over 2. That's going to be 4 times root 3 over 2 squared minus 1. That is going to be basically 4 times 3/4 minus 1. They cancel out, so we're left with 2. So we can see that K is equal to 2. Okay, we verified that. All right, so K is equal to 2 as we're required to verify. Okay, so now we can move on to part B. So B has got 2 parts to it. It's B part 1, find the x dy in terms of y. So I'm going to do that first. So we have y equals, or x equals 4 sine squared y minus 1. Now what I like to do in this type of case is I like to write this as I did earlier. This is like sine of y squared minus 1. So if I want to differentiate x with respect to y, so I'm going to find the x dy. So here I have to use a chain rule. It's like a function inside a function. So the main function is something raised to a power. So I multiply by the power. So that's going to give me 4 times 2, which is 8. And then I take 1 from the power. So it becomes sine y to the power of 1, basically. And then I have to multiply by the differential of what's inside the function. So the differential of sine y is positive cosine y. Okay, and the minus 1 becomes 0 when you differentiate it. So we can say the x dy, therefore, is going to be 8 times sine y times cosine y. Okay, so that's what they're asking us to find. And there's the answer to part B, part 1. So 8 sine y cosine y. And then we have here question 9, part B, part 2. So we already found this. The x dy is 8 sine y cosine y. We found that from part 1. So it says hence, so using your answer, show that dy dx is equal to 1 over 2 times root x plus 1 times root of 3 minus x. Okay, so we've got to do this question now. Okay, so now we have dx dy. We have dx dy. So dx dy we have as 8 sine y times cosine y. we want to find dy dx. So we can write this as its reciprocal. So dy dx. In fact, you know what I'll do? I'll keep it like this first. I'll try to make this look like that, and then I'll write it as the reciprocal at the end. So I need to rewrite sine y and cosine y in terms of x. Right? So I need to do that. That's what I need to do. So for sine y, it's pretty simple because I can see what we have here, what we started with, which is x equals 4 sine squared y minus 1. I can rearrange this to make sine y the subject. So I have to add 1 to both sides and divide by 4. That will give me sine squared of y. And I know that the sine of y is going to be plus or minus the square root of x plus 1 over 4. Okay, now because y is between 0 and pi over 2, then the sine of y will always be positive. So I can say that the sine of y is going to be just the positive square root of x plus 1 over the square root of 4, which is 2. Okay, so that's the sine of y. So I can replace the sine of y with this. Okay, so this can replace the sine of y. So I've got sine of y. So the sine of y can be replaced with the square root of x plus 1 over 2. All right. Now, how about the cosine of y? Now, I can find the cosine of y in a number of ways. One way I can do it is by using identities. Another way is by using a triangle using this. Now, I like to use a triangle. I'll show you both ways, but I prefer to use this triangle method. So I know that, just make this smaller. I know that we are in the first quadrant, so we don't have to worry about anything except that we're going to be positive for y. So the angle y is somewhere in this first quadrant. So the sine, cosine, and tangent will always be positive. So we know that the sine of y is equal to root of x plus 1 over 2. This would be like the opposite, and this would be the hypotenuse. So the hypotenuse would be 2, and the opposite would be root of x plus 1. Right? If I want to find what this is here, if I want to find the cosine of y, I need to know the adjacent side. Okay, and the adjacent side is going to be the square root of the hypotenuse squared, which is 4, minus this squared, which is x plus 1. If I square this, I get x plus 1. That gives you 4 minus 1 minus x. That's 3 minus x. So this adjacent side is the root of 3 minus x. So I can say, therefore, that the cosine of y is equal to root of 3 minus x over 2. Okay, so I can say dx dy is equal to 8 times the sine of y, which is root of x plus 1 over 2, times the cosine of y, which, as we can see now, we can replace the cosine of y with this. Okay, so that's root of 3 minus x over 2. So 2 times 2 is 4, and that cancels out. So you're left with here 4 divided by 2, which is 2. So you got dx dy is equal to 2 times the square root of x plus 1 times the square root of 3 minus x. Okay, and we can see that we want to find dy dx. We just write this as its reciprocal. So this is like all of this over 1. So therefore, dy dx is all of that flipped upside down, which is what we had to show. Okay, and there's the answer for this question. As I said, I would also show you a different way of dealing with this. We could have used identities here. Okay, so I know sine y equals root of x plus 1 over 2. And I also know that sine squared y plus cosine squared y is equal to 1. So I can say cosine squared y is 1 minus sine squared y, which is 1 minus, and if you square this, you're going to get x plus 1 over 4, right? So this is going to be basically, if you rearrange that, that's going to be 4 minus x plus 1 all over 4. That's cosine squared y. Okay, which gives you 4 minus x and 4 minus 1, so that'll be 3 minus x over 4. That's cosine squared y. Therefore, cosine of y is going to be the positive square root of 3 minus x over 2. Okay, which is what we found here by using the triangle. Okay, both methods are perfectly fine. Identity or triangle, they both work. Good. So there's the answer to 9b, part 1 and 2. And now we're going to move on to part C. So it says the normal to the curve at P cuts the x-axis at the point N. Find the exact area of the triangle OPN, where O is the origin. Give your answer in the form of A pi plus B pi squared, where A and B are constant. So the normal to a curve is perpendicular to its tangent. And the tangent to a curve shares the gradient of the curve at the point where the tangent touches the curve. So here you have the tangent, and the normal would be a line which is perpendicular to the tangent, which will cut it at right angles, and it will also go through the same point P. So this is the normal, which we have to be considering here, and this is the tangent. Okay, so the normal to the curve cuts the x-axis at the point N. So we have to find the area of this triangle, which I'll draw in a different color. We have to find the area of the triangle that goes from O to P to N. That's what we have to find, the area of this triangle. Okay, in order for us to find the area of this triangle, we need to know the coordinates of the point N. And in order for us to know the coordinates of the point N, we need to know the equation of the normal to the curve. Okay, so we need to find the equation of the normal. So first step is to find the equation of a straight line. We need two things. We need the gradient of the normal, and we need to know a point on the normal. And we know that the point on the normal is the point P, which is 2 pi over 3. That's a point on the normal. So we have the point, that's fine. We have to find the gradient of the normal. So the first thing we do is we find the gradient of the tangent. Okay, so the gradient of the tangent we can find by using what we already found or were given even in the last question. So even if you couldn't find it, it's given to you, so that's perfectly good. Now, one of the students was asking on the channel, sir, there's no error carried forward, so I can't use the answer from part B, I won't get any marks for part C. No, that's not what it means by error carried forward, right? The reason why they gave you the answer here is such so that you don't lose marks if you got part B wrong. Here, part C now doesn't depend on your answer for part B. If you couldn't get this, you can use this in part C. Error carried forward is when, for example, if you get an answer wrong in part B and you have to use that answer in part C. Okay, if there is error carried forward in that question, then they won't take off the marks for your answer in part C if it says ECF. But in most cases, they would take off the answer mark, but not the method marks. Right? So if you get something wrong in one part and you use that wrong answer correctly in the next part, you get the method marks. Sometimes they might give you, the error carried forward, so they might give you the mark for the answer even though it's wrong. Sometimes they might not give you the mark for the answer because the answer is not, of course, the correct answer at the end. But you can use previous parts of a question that's given like this, and you won't lose any marks from the next part of the question if you couldn't get that yourself. That's not what, the student was worried about that. That's not what it means at all. Okay, so the gradient of the tangent, we know at point P, x equals 2. So I'm going to take this, I'll place x with 2. So I have 2 times the square root of 2 plus 1 times the square root of 3 minus 2. So this gives you 1 over, this is 2 times root 3 times 1. Okay, root of 3 minus 2 is 1. So this is the gradient of the tangent, okay, at P. We need the gradient of the normal. Now, I was going to rationalize this, but there's no need to. Why? Because the gradient of the normal is going to be the negative reciprocal of this. So I'm going to take this, I'm going to change its sign, I'm going to write it upside down, so it's 2 root 3. Okay, so that's the gradient of the normal to the curve at the point P, right? So now we have enough information for us to work out the equation of the line. In fact, we don't even need the equation of the line. We just need to know where that line hits the x-axis. So I'm going to set it up. So I'll say y minus y1 equals m times x minus x1. So you have y minus y1, okay, which is pi over 3, equals m, which is minus 2 root 3 times x minus x1, which is 2. Now we want to know where it hits the x-axis. So I don't actually need the equation of the line. I know at the x-axis y equals 0. So I can straight away here put y equals 0. So I have 0 minus pi over 3 equals minus 2 root 3 times x minus 2. So I can solve for x straight away now. So I can, let's see how we can do this in an easy way. What I'll do is I'll divide both sides by minus 2 root 3. So you're going to end up with minus pi over 3 times minus 2 root 3. And then that's going to be equal to x minus 2. So the minuses will cancel out. That's going to give you pi over 6 root 3 equals x minus 2. Okay, 3 times minus, that's right. And what I'm going to do now is I'm going to rationalize the denominator. So I'll multiply both the top and bottom by root 3 here. So I'll end up with pi times root 3 over 6 times 3, which is 18, equals x minus 2. So x is going to be equal to 2 plus pi root 3 over 18. How do they want us to give the answer? All right, so the answer has to be like this. So that is basically the coordinates of n. Those are the coordinates of n. Okay, which in fact what I'll do is I'll just write it as one fraction. Okay, if I write it as one fraction, then this is something over 18. I have to multiply by 2. That's going to be 36 over 18 is 2. That's going to be 36 plus pi times root 3 over 18. Okay, so that's the coordinates of n. So we have this triangle that looks like this. Okay, it's a right angle triangle. It's not a right angle triangle, but it doesn't need to be. Now, some people, this is a very, very common question that I get. Okay, and I want to make sure that it's understood. They say, sir, this is not a right angle triangle. So therefore, how can we use a half base times height on this triangle? Well, we know that any triangle that has the same base and the same height, vertical height, and the vertical height of the triangle is the height between the base and the vertex. That's the vertical height. It doesn't have to be a right angle triangle. Okay, this is the vertical height. It's the perpendicular height between the base and the vertex. So the triangle itself doesn't have to be right angle. Any triangle that has that base and that distance between the vertex and the base is going to have an area of a half times the base times the height. So in this case, the base is from the origin O to N. Okay, so this is O, this is N, and that is 36 plus pi root 3 over 18. And the height of this is the y coordinate of P, which is pi over 3. So the height of this is pi over 3. Okay, so the area of this triangle, is a half times the base, which is 36 plus pi times root 3 over 18 times the height, which is pi over 3. And they want this expressed as separate terms. A pi plus b pi squared. Okay, so let's just work this out. The 18, all right, this is in brackets here. Be careful about that. So you're going to have a half, that's times 2 times 3, that's 6 times 18. Okay, so let's work that out. 6 times 18, that's 108. So you're going to have 1 over 108 pi times 36 plus pi root 3. So you got 36 over 108. What's that? 36 divided by 108. That gives us 1/3. So that's 1/3 pi plus, and you're going to have root 3 over 108 pi squared. That's the area of this triangle in the form A and B. We want the exact area, so leave it in terms of pi and the root, the third, so 1/3 pi plus root 3 over 108 pi squared. So this is square units. And that is the end of question number 9 part C. I hope that was clear. Other questions from this particular paper, other questions on this paper are found in the playlist that will appear at the top right of the screen at the end of this video. You're going to find the questions dealing with differentiation in general and differentiation of trig functions. I'm not sure if I've got a playlist for inverse trig functions, but if I do, I'll put that there. Okay, so thank you for watching. I hope you learned something, benefited, and enjoyed the maths that we did. Thank you for watching, and see you soon.